Hello and welcome to SudoKanard. Recently there was the qualifying round for the German Sudoku Championship, that's DSM, Deutsche Sudoku Meisterschaft, and I've chosen to solve on video a few puzzles of them, and I've chosen to begin with this Gamma and Epsilon Sudoku by my friend Philipp Blume. So the rules are simple. On top of the usual Sudoku rules, you have white dots, which give the difference between the two digits, and black dots, which give the ratio between the two digits. And this is called gamma and epsilon because gamma is the third letter of the Greek alphabet, and there are threes, and epsilon is the fifth letter of the Greek alphabet for all those differences of 5. It's my belief that the inventor of this variation and the promoter of this variation is Toganus, but you can tell me if I'm mistaken. So it was worth 46 points, which was not that much compared to other puzzles. But those other puzzles will appear on the channel later. So let's begin with this. So this can only be 3 surrounded by 1 and 9. So with this difference of 5, it has to be 4 or 6. Here it could be, well, basically anything. Where could we look? There's quite a lot of action. Oh, and something worth mentioning is that there's no negative rule. So there could be a difference of 5 here, there could be a ratio of 3 here. If it's not mentioned, then it has no impact. A lot is happening here, and something I'm noticing is that 5 can't appear on any of those symbols, so 5 has to be here in this 3x3 block. So in this 3x3 block, 5 won't appear here, so it will be here or there. Not sure it will be useful. What can we have here? So this could be 2 and 6. This could be 3 here and 1 or 9 here, in which case that would be 2 and 6. Note that 2 won't be here because it would need a 7 here. There's no 2 in those cells actually. So this could be 6 or 1, 3, 9. Oh, but would 6 work? 6 would be with a 2. I solved it during the contest and I really don't remember how I did it. But something of interest is that this and that, there are here 3 digits that may be in a ratio of 1 to 3. And there are 4 options, which are 1, 2, 6, and 9. Here as well, here as well. And here. So that's 4 options. I don't remember doing this. I think, oh no, sorry, I've missed this. This here can't be 1, 3, or 9, so it has to be 2 or 6, and this must be 2 or 6 as well. But 2 here would put a 7 here, so it has to be a 6. That's a 2. So this is a 1, and now this can only be 3 and 9. So this is 3, this is 9. This could still be a 1 here, a 3 there. are 2 and 6. But note that 2 here we need a 7, which is not possible. 6 here we need a 1, which is not possible. So it has to be 3 and 1. And those now must be 2 and 6. And this is 1 or 7. And this is 8. Alright, so now we're doing something. This row still needs 2, 4, 5, and 7. So this is 2, 4, 7. This is 2, 4, 7. 2 makes this a 7. 7 makes this a 2, so it's not possible. And 4 makes this a 9. And this won't be a 2, so the candidates are 4, 7, and 5. Here, what do we have? It won't be 1 and 6, won't be 2 and 7, won't be 3 and 8, so it has to be 4 and 9. And now we know that this is 1 and 6, and this is 9. This doesn't include a 4, so this is not 7. Sorry. So this now has to be 1, that's a 6, that's a 2, and this is now an 8, and this a 3. This now can't include a 3, so it has to be 2 and 6, and 2 is on this side, 6 is there. 6 is not here, 6 is not here, so there has to be a 6 here, and there has to be a 1 over them. So, oh, and this now must be 2 and 6. This column still needs 5, 7, and 8. And by Sudoku, this box has a 6 here. This difference of 5 now, what can it be? It can only be 4 and 9. With the remaining digits, 1 has to go here. This is 5, 7, or 8. This column still needs 2 and 3. It's not here. They are somewhere here. This can only be 5, 7, or 8. This here can only be 4 and 9 again. Here, what are the options? I think 6 and 8 is the only one. 2, 3, 4, yes, that's 6 and 8 actually. The column still needs 2, 4, and 5. So there's a 2 down there. Here, 2, 4, 5, 7. 2 wouldn't work. It would need a 7 here. 5 wouldn't work. So it's 4 or 7. 7 would make this a 2, but there's a 2 here. So that's a 4, that's a 9. That's a 2. That's not 4. This is 5 or 7. Oh, this 4 makes this a 9 and this a 4. And oh, now this is 4, this is 9. I still need 5, 7, and 8 on this row. This is not 7. By Sudoku, this is a 2. I need a 4 down there. So those are not 4s. This is 4. 5, 8, and 3. Oh, and this difference of 5, this is not 1, so this has to be 2, 6, that's 7, that's 9, that's 4, which I already had. This 7 now bounces back resolve those digits. This 8 just eliminates options. 4 and 7 here, there's a 7 on the row, 4, 7, that's a 9, that's a 4. Here I need 1, 6, and 8. What then? So now it's just Sudoku. Yes, we already have all the rest. So this is 5 and 8. This 2 goes there, 3 goes here. I need a 1. 1 is here. 5, 7, or 8. 9 can only go here. I need a 4 in this column. It can only go here. This is 3, 5, or 8. I need a 3 down there. It must be here. This is 5 or 8. This 3 gives the 2, the 3. The 5, the 2. That's not a 5. And that's not a 7. This 5 now gives us all of this. No 5s here. That's an 8. That's a 7. That's an 8. That's a 3. This now is an 8, 5, 8. 6 here. 1 here. 8 there. So now it's just doing some cleanup. 1, 5, 6. 6 has to go here. 1 here, 5 here. 7, 5, 7. 4, 5, and that's a 9. Alright, I think that's it. Well, I think that's it. I'm scanning for mistakes. I don't find any. I thought there would be the fireworks in the end, but I must have forgotten to put fireworks. So the beginning was a bit tricky, or it was just that I didn't notice the impact of this on this. After that, it was a smooth sail, actually. Thanks for watching this video, and see you pretty soon with other puzzles from this qualifying round. Hey.